Effects of changing dimensions proportionally, we're at 10.5. We have 10 previous videos for Chapter 10 that are linked in the description if you need them. When we change the dimensions of a figure proportionally, we change its area, perimeter, and for circles we change its circumference. The effect it has on a figure will depend on whether we change one dimension or more than one dimension. Doubling only the bases, our square becomes a rectangle with double the area. So if we have a 1-inch square and we just double the base down here, we'd have 1 by 2 inch, which gives us a rectangle. And instead of a 1-inch square, we've got a 1 by 2 inch square. We've doubled the area. Doubling the base and the height, we get a larger square with 4 times the area. We can discuss the effects of changing one dimension. We can describe the effect of each change on the area of this given figure. So we've got this parallelogram, and its original dimensions are, we have a base of 12 centimeters, and yeah, the base is on the side. We have a height that's perpendicular to the base, that's 9 centimeters. So the area is base times height, that's 12 times 9, that's 108 centimeters squared. When we double the height, we have the same base of 12, but now the height is doubled. 2 times 9, the height is 18 centimeters. Now our area base times height is 12 times 18, which is 216 centimeters squared. And when the height is doubled, the area is doubled. We went from 108 to 216. That's double. A triangle with vertices ABC, A is 1, 1, B is 6, 1, and C is 3, 5, has its base length multiplied by half. So the first thing we do is draw this triangle from these ordered pairs, and we connect the vertices. We find the base and the height. It's 5 units across, it's 4 units up. Now we find the area for the original dimensions, these given points. Areas for a triangle is half base height, so we've got half times 5 times 4, which is half times 20, which is equal to 10 units square. Now we find the area when the base is multiplied by half. So 5 times a half is equal to 2.5. That's our new base measure. We have the same height, so we're going to do 2.5 times 4 times that half. That's going to give us 5 units squared. 5 is equal to half times 10. That was our original area. So if the base is multiplied by half, the area is multiplied by half. Now we're going to talk about the effects of changing dimensions proportionally. We can describe the effect of the change on each perimeter or circumference and the area of the given figure. So we have a base and height of a rectangle with a base that's equal to 8 meters and a height that's equal to 3 meters. And they're both multiplied by 5. So now we're going to multiply both measures by 5, not just one of them like we did before. Our original dimensions were 8 meters by 3 meters. To find the perimeter of a rectangle, we do 2 times the base plus 2 times the height. So we've got 2 times 8, which is 16, plus 2 times 3, which is 6. That gives us 22 meters for our perimeter. And we do base times height for the area of a rectangle, so we've got 8 times 3, which is 24 meters squared. Now we need to multiply both the base and the height by 5. 8 times 5 is 40, 3 times 5 is 15, so now for our perimeter we have 2 times 40 plus 2 times 15, which is equal to 110 meters. Our new area would be the 40 times the 15, which is 600 meters squared. So the perimeter is multiplied by 5. 5 times 22 is 110. And the area is multiplied by 5 squared, or 25. 24 times 25 is 600. 5 squared times 24 is equal to 600. So do you see how the perimeter got multiplied by 5, but the area was multiplied by 5 square? The radius of circle A, right here, is multiplied by 1/3. Well, we can see it gave us the radius is 9 inches. So for circumference, for our original dimensions, we have 2 pi r. That means we have 2 pi 9. We multiply the 2 and 9 and get 18 pi inches for our circumference. For our area, it's pi r squared, so we're going to square that 9 and get 81 pi inches squared. We need to multiply the radius by 1/3. That's going to give us a 3. 9 times a third is 3. So that means our circumference is 2 pi 3. We multiply the 2 and the 3 and get 6 pi inches for our new circumference. And the area is pi r squared, so we're going to do pi times 3 squared, which is 9 pi inches squared. We had an original circumference of 18 pi. The circumference is multiplied by 1/3. We got 6 pi. 18 times 1/3 is 6. And the area is multiplied by 1/3 square, or 1/9. Our original area was 81 pi. If we multiply that by 1/9, we get 9 pi inches squared. When all the dimensions of a figure are changed proportionally, the figure will be similar to the original figure. So the effects of changing dimensions proportionally, for change in dimensions, all the dimensions are multiplied by a. For a change in perimeter or circumference, they change by a factor of a. And a change in area will change by a factor of a squared. For the effects of changing area, what happens to the sides? Well, a square has side lengths of 5 centimeters. If the area is tripled, what happens to the side length? The area of the original square is side squared, isn't it? So we're going to do 5 times 5, 5 squared, which is 25 centimeters squared. Well, if the area is tripled, it's multiplied by 3. So 25 times 3 is 75 centimeters squared. We can set that new area to equal s squared. It equals that 75. We remove the 2, we put the radical sign around this side, and we find the square root of 75, which is equal to 5 square root of 3, which just means we're doing square root of 3 times 5, that side length. When we triple the area of a square, we multiply the side length by square root of 3. When we double the area of a square, we multiply the side length by square root of 2. So here's what's happening. If we've got an area of 4 and we double this area to an 8, this side length 2 is multiplied by square root of 2. So that means all the sides are this measure, aren't they? Because that's a square. That's the definition of a square. If we triple the area from a 4 to a 12, what's happening to the side is we're multiplying it by square root of 3. So all the sides are equal to 2 square root of 3. Here we have a circle with a 6-inch radius. If the area is doubled, what happens to the circumference? So let's look at the original area. Area is pi r squared for a circle. So that means we've got pi 6 squared, which means we have 36 pi inches squared. For our circumference, we've got 2 pi r, so we've got 2 pi 6. We multiply the 2 and the 6, and we get 12 pi inches for our circumference. If the area of 36 pi inches squared is doubled, we have 2 times 36 pi. That would be 72 pi inches squared. Now we set the new area to pi r squared. So we have pi r squared is equal to 72 pi. We can divide both sides by pi. This cancels out as a 1. This cancels out as a 1. So now we just have the radius squared is equal to 72. We take the square root of both sides, take that little 2, remove it by putting a radical sign around the 72. Square root of 72 is 6 square root of 2. And 6 was our original radius. The next thing we do is substitute 6 square root of 2 for r, our radius, in the circumference formula. And 2 pi r becomes 2 pi 6 square root of 2. We multiply the 2 and the 6, we get 12 square root of 2 pi. Notice that 12 square root of 2 pi is equal to the square root of 2 times 12 pi. We can multiply in any order. The circumference of a circle is multiplied by square root of 2 when the area is doubled. And the circumference of a circle is multiplied by square root of 3 when the area is tripled. So now I'm going to show you how all of this can help us. I'm going to show you a slow method of solving a problem versus a fast method of solving a problem. A restaurant has a weekly ad in a local newspaper that is 2 inches wide and 4 inches high, and it costs $36.75 per week. And the cost of each ad is based on its area. If the restaurant owner doubles the width and height of the ad, how much will the new ad cost? So first we find the area of the original ad. It's a 2 by 4, and that gives us an area of 8 inches squared. That's $36.75. So here's the slow method of solving this. We find the cost per square inch because that's what the ad is based on. It's by area. So we take the $36.75 and we divide it by 8, the area of that ad. And we find out that it costs $4.59375 per square inch. We double the width and height like we're supposed to, and we get a 4 by 8 for our new width and height. So our new area is 32 inches squared. Now we can multiply the new area by the cost per square inch. We know that's each square inch. We've got 32 of them. Comes out as $147 for the larger ad. Now that's the slow way to do it. So here's the fast way to do it. We can save time by following the rule that we had previously in the video. We can change the area of a rectangle proportionally by multiplying the area by a squared. We change it by a factor of a squared. So if we've got a 2 by 4 rectangle, we can double the area. Double means 2. We just multiply that area of 8 by 2 squared. That's 8 times 4. That's 32 inches squared. We can also, because that's based on the area, take the $36.75 and multiply it by 2 squared to double it. We get $147. Much quicker. We could quickly triple the area by multiplying the 8 by 3 squared, or quadruple it by multiplying the 8 by 4 squared. Much faster, right? There's several ways to double the area of a rectangle. We talked about a square, we talked about a circle. For a rectangle, we can just double the base. That'll double the area. Or we could leave the base alone and just double the height. That would double the area. We could also multiply both the base and the height by square root of 2. We do the base times square root of 2 times the height times square root of 2. If we have an area of 8, doubling it's easy. That's 16. That's just 8 times 2. But what happens to the sides? Well, we multiply this side 2 by a square root of 2, which is approximately 2.82843, and we multiply this 4 by square root of 2, which is approximately 5.65685. Now that area is doubled, and the sides were multiplied by square root of 2 because we doubled. So that's it for 10.5. We're going to do 10.6 next, which is broken up into 3 parts. Probability, which is going to remind you of what we learned about probability in middle school and in algebra. And then we're going to talk about geometric probability in 10.6b. I'm going to finish that with using geometric probability to estimate pi in 10.6c. When we get to chapter 13, we're going to talk a lot more about probability. So chapter 13 is going to be permutations, combinations, theoretical probability, experimental probability. We're even going to talk about factorials. So I hope I'll see you there. So we've got 3 more lessons until we get to, 3 more videos until we get to chapter 11. And I hope you were able to understand about changing one dimension or changing the dimensions proportionally. And I hope you have a great day. Bye.